Hi guys, so we're going to talk about complex numbers now. These are your numbers where you have imaginary numbers. And so let's look at the equation x squared plus 1 is equal to 0. When we did factoring, the reason we do this second is because when we did factoring, I would have said that this was a prime factor and it does not have an actual factor. Okay, and the reason is because if you try to factor this and you do the x method, you would want something that multiplies to give you 1 but adds up to 0. Well, to get a positive, you either have to have a positive and a positive, or a negative and a negative. And the other situation would be if you had a positive and a negative, and let's just pretend that we do. But you'll see the flaw in that thinking. So if we had two positives, 1 and 1, well, 1 times 1 is 1. 1 plus 1 is 2, so that doesn't match this. So this didn't factor. This one didn't work. If we do this one, two negatives, that's 1 and 1. Negative 1 times negative 1 is 1. Adds up to negative 2, though, so this one doesn't work. And then finally, if we do 1 and 1, well, this is negative 1. It adds up to 0, but it multiplies to negative 1, not 1, so this one doesn't work. And so if we wanted to factor this, or solve this, we could do this is equal to 0. We would subtract the 1. X squared is equal to negative 1, and then we take the square root, and x is equal to plus or minus I. Okay, so now we have x being equal to plus or negative I, and that is your solution. That's the imaginary number I. So we define the square root of negative 1 is equal to I. Okay, now when you add and subtract numbers that involve I, for instance, if we have the square root of negative 4 negative 1, well, this is simply 2i plus I, which is equal to 3i. Okay, and the reason is because the square root of 4 is 2, and the square root of negative 1 is I, and then so we just get the square root of 2i plus I. So let's look at some examples where we have real numbers mixed with conjugate or complex numbers. So if we have 2 plus 3i plus 2 minus 3i. No, let's do plus 3i. Oops, I didn't want that. I wanted a parenthesis. Then if we're going to add these, we add them real parts. These are the real parts. The 2 and technically the 3 is real. The I is the only imaginary part. But we'll add the 2 and the 2, and that's 4. And then 3i plus 3i is, you guessed it, 3i plus 3i is 6i. Just like in regular algebra, if you have 2x plus 2x, that's 4x. 3i plus 3i is 6i. Okay, so let's do another example. If we do something like 2 minus I, not plus, minus 3i plus 4. Let's say we have that. This is a little bit different because we have to account for the fact that the negative here needs to be distributed to these two things. So we have 2 minus I, that's still the same, we don't need the parentheses. And then distribute negative 3i and negative 4. Well, 2 minus 4 is negative 2. Negative I minus 3i is negative 4i. That is your answer. Just combine like terms and you have your answer. It's no different than regular intermediate algebra. Next, multiplying complex numbers. So if I do, actually, sorry about that. Let's deal with the i's and their powers first because that's important to this. So what we're going to do, if I look at I, we said that that was the square root of negative 1. If I look at I squared, well, that's equal to the square root of negative 1 times the square root of negative 1, which is equal to just negative 1. That's square root of negative 1 squared. Okay. If I look at I to the third, what is that? Well, that's going to simply be, well, we know I to the third is I squared times I. Well, we know I squared is negative 1 times I. So this is negative I. And then we have I to the fourth, which is just I squared times I squared, which is equal to negative 1 times negative 1, which is equal to 1. Okay, so let's look at I to the fifth. That's I to the 4th times I, which is equal to 1 times I, which is equal to I. I to the 6th is just I to the 4th times I squared, which is just 1 times -1, which is -1, and you can kind of see a pattern emerging. The quick way to deal with this is to go I to the 0 is 1, because anything to the 0 power is 1. I to the I to the 1 is I to the 2 is -1, and I to the 3 is -I. Remember this list because that list will help you do this pretty quickly. So, what if I asked you what I to the 45th is? Well, what you'd do is you'd say, oh, this is I to the, well, I guess we could write it as powers, but I would just go like this, 45, divide it by 4, that's 1 minus 4, that's 1, and then we have a remainder here is 1, so then this is I to the 1, which is equal to I. Okay, so we could say this thing is I. What if I said, what is I to the 209? I'm going to show you a quick trick that always works. You can simply just do the last 2 digits if it's longer than 2 digits. If we do 9 divided by 4, oops, that looks like a square root sign, sorry, 9 divided by 4, this is 2, remainder is 1, so then I to the 209 is equal to I to the 1, which is I. If I did I to the 2058, okay, let's do that. Then I do 58, divide by 4, that's 1, that's 4, that's 2, so the remainder here is 2. So this is equal to I squared, which is equal to -1. Okay, and so now that we have that down, let's look at the multiplication bit. So if we do the multiplication, if I do I times 3I, I have 3I squared. Well, we said that I squared is -1, which is equal to -3. If I do 2 plus 3I and 4 minus I and multiply these together, notice this is multiplication, not adding and subtracting, because we do not have a sign in the middle like here. Okay, there's no sign there. So now we are going to distribute. 2 times 4 is 8. 2 times -1 is -2I. 3I times 4 is positive 12I. And 3I times -1 is -3I squared. Well, let's combine like terms. Well, this is -3 times -1. These combine to give us positive 10I. And we have an 8. So 8 plus 10I plus 3, which means this is 11 plus 10I. And that is our multiplication for this. So the main things to remember about that, if this has nothing in between it, it is a multiplication, and you must distribute like I did. Notice I distributed, I foiled it. FOIL, it's short for first terms. First being these 2 first red ones that I just marked. Outside, that would be your blue ones that I'm marking. The next one is inside, and I'll mark that with green. These 2 are green. And the last one is last. And we're marking those with brown. The last ones are these 2. And so we basically multiplied in that order. The order you multiply does not necessarily matter, but I keep doing it that way to keep it consistent, so I always get the same answer, hopefully. I'm going to end this video here. I'll do the conjugates and the rationalizing the denominator next. So we'll see you in the next video.